Back to the classroom. My name is Mr. Wong. Today we're going to be explaining the exam, in this case the 2022 or 2020. Welcome back to the classroom. My name is Mr. Wong. Today we're going to explain the exam, the 2020 PEM physics paper, question 22. This is going to align with module 1, inquiry question 1, which is all about kinematics. So let's have a read. We have Harold riding his bike at 20 meters per second. Notices a rough patch on the road ahead. He travels over the 24-meter rough patch in 1.5 seconds. Calculate his velocity as he exits the rough patch. So in this case, we're using one of the three kinematics equations. What we have is a initial velocity, u. We are trying to find the final velocity, v. We have a patch or distance, displacement of s, and then we have a time of 1.5 seconds. So let's have a look at the equations we can use. Three equations you could potentially use. We have s equals ut plus half at squared. We have final velocity equals to u plus at, and then the last one, v squared u squared plus as2. So let's have a look which one of these three would be the most appropriate for this question here. So the most appropriate one we could use is this equation here. Okay, we have displacement, we have initial velocity, we have time. We can find acceleration, and from there we can find final velocity. So let's give that a go. First of all, substitute your values into the equation. So 24 equals to 20 equals to, or times 1.5 plus half a, and then 1.5 squared. I guess the most important thing you want to make sure of is that you've got your direction. So if we actually read the question, and assuming that Harold is going to the right, at no point in this question does it suggest that his final velocity is going the opposite direction as before. So we can assume that they're both going the same direction. Okay, so we can just denote that as the positive direction. Next, what we want to do is to then adjust our equations around so we can have a as the subject of the equation. So we get it's 24 subtracted by the 20 times 15, or 1.5, sorry, equals to half a 1.5 square. Okay, so there's that. We want to move the 2 over, so it becomes 2. We'll go with the big square brackets. 20 times 1.5, and then divided by this 1.5 square here. And that is our acceleration. So let's plug that into the calculator and see what we get. We get an acceleration of negative 5.333 repeater meters per second squared, because that's what acceleration is. Okay, so we're going to leave that as it is right now. You can round it off to 3 sig figs, they do allow for that. But let's just keep it non-rounded, and then what we want to find is the velocity. So, or the final velocity, that is. So we're trying to find v here. So let's substitute that into our equation. V is equal to u, which is 20, plus our negative 5.33 repeater times the time 1.5 seconds. And what we'll get here is 12 meters per a second, and it is the positive direction, so it's still going in this location here. So that's how you do one of these kinematics equations. Make sure you identify the numbers that we have here, so make sure you label the symbols. Write out the equations. If you can't remember which one should be most appropriate to use, whichever one that gives you the most information, use that in the equation. Okay, so this is how you do the equation, that's how you do the response, and that ends our component of explaining the exam. Hopefully you have a better understanding of how to do these kind of kinematic equations, and hopefully that's of use to you. Anyhow, take care, and I hope to see you come back and watch some more videos.